Hello and welcome. I am Dr. Pauline Fu. In this video, I will present counting techniques. If I have 3 textbooks, mathematics, English, and history, I ask you to put these 3 textbooks on the bookshelf. How many different ways you can arrange these 3 textbooks? This is a problem of counting. In this video, I will present techniques for counting. At the end of this lecture, you would be able to solve counting problems using multiplication rule, solve counting problems using permutations, solve counting problems using combinations, solve counting problems involving permutations with non-distinct items, compute probabilities involving permutations and combinations. So first, let's look at multiplication rule of counting. If a task consists of a sequence of choices in which there are P selections for the first choice, Q selections for the second choice, R selections for the third choice, and so on, then the task of making these selections can be done in how many ways? P times Q times R, etc. Okay. For example, if you want to go from point A to point C, okay, you are going to pass through point B. There are 2 different ways from A to B, 3 different ways from B to C. So how many total ways you can get from point A to point C? It is 2 times 3. Okay. Let's take a look at an example. A mixed price dinner at Marbencan restaurant provides the following choices: appetizer, soup or salad, entree, baked chicken, broiled beef patty, baby beef liver, or roast beef, angels, dessert, ice cream or cheesecake. How many different menus can be ordered? So that is a typical example of counting the possible meals. So this example, if you read the question, so for appetizer, we have 2 choices to select appetizer. And for entrees, we have 4 choices. Okay. And for dessert, we have 2 choices. So total we have 2 multiplied 4 multiplied 2. Total we have 16 different orders. Okay. So next, we define a terminology, factorial symbol, n factorial, n followed by exclamation mark. The definition is n factorial equal to n times n minus 1 times n minus 2, etc., times 3 times 2 times 1. By definition, we also define 0 factorial equal to 1 and 1 factorial equal to 1. Next, we introduce the concept permutation. Number of permutations of n distinct objects taken are at a time. So for example, if I have 10 textbooks, I want to select 3 textbooks. How many different ways can I choose? Okay. There are some restrictions. One, n objects are distinct. If you have 10 textbooks, those 10 textbooks are totally different. You cannot have, for example, 2 mathematics textbooks. Number 2, repetition of objects is not allowed. Number 3, order is important. Okay, if you choose textbook, mathematics, English, it is different as you choose textbook, English and mathematics. So order is important. So anyway, the permutation formula. So you want to choose R object from N object, and order is important. The formula is n factorial divided by n minus r factorial. For example, if you select if you select 3 textbooks from 10 textbooks and the order is important, how many different ways? It is P, n equal to 10, r equal to 3, and you calculate this factorial, use calculator or by hand. And in Excel, you can type in equal PERMUT, opening bracket, 10, comma, 3, closing bracket, you'll get the number. Let's take a look at example. How many ways can horses in a 10-horse race finish first, second, and third? So first, we want to make sure the 10 horses are distinct. Once a horse crosses the finish line, that horse will not cross the finish line again. And in a race, order is important. Okay. The first and the second is important. We have a permutation of n objects taking 3 at a time. So this example is like select 3 textbooks from 10 textbooks if order is important, okay? So the solution is, this is a permutation problem. We want to choose 3 from 10, so you use permutation, okay? And it is 10 factorial divided by 3, 10 minus 3 factorial. And you do a little bit calculation, you get final result, 720 ways. Okay. So the answer, final answer is there are 720 ways, okay, a horse in a 10-horse race finish first, second, and third. Next, so far we talked about permutation. Next, we'll use combination. A combination is a collection without regard to order. So order is not important in combination, in which R objects are chosen from N distinct objects without repetition. So we use simple NCR represents the number of combinations of N distinct objects taken R at a time. So combination order does not matter. Permutation order matters. The number of combinations of N distinct objects taken R at a time. We have some restrictions. Number one, the N objects are distinct. 2, repetition of object is not allowed. 3, order is not important. This is the difference between combination and permutation. In permutation, order is important. In combination, order is not important. So the formula for combination, NCR equal to N factorial divided R factorial multiply N minus R factorial. So let's look at this example. Simple random samples. How many different simple random samples of size 4 can be obtained from a population whose size is 20? Okay, so I want to select 4 objects from 20. How many different ways I can select these 4 objects? Okay. So let's clarify some requirements. The 20 individuals in the population are distinct, and the order in which individuals are selected is unimportant. Thus, the number of simple random samples of size 4 from a population of size 20 is a combination of 20 objects taken 4 at a time. So we use combination formula. Okay, we want to take 4 from 20. So 20 C4 equal to 20 factorial divide 4 factorial multiply 20 minus 4 factorial, and do a little bit calculation. You come up with 4,845. Final answer, there are 4,845 different simple random samples of size 4 from a population whose size is 20. And this question I can phrase differently. For example, I want to select 4 students from 20 students to attend a conference. How many different ways I can select these 4 students? The answer is 4,845. Okay, select 4 students from 20 students. If the question becomes, I want to select 4 students from 20 students, and I will assign the positions for these 4 students. 1, president. The second, vice president. Number 3, treasury. And number 4, treasury. Maybe accountant. Okay, so I'll assign 4 different positions. In that case, you must use permutation because order matters. So I repeat the question. I want to select 4 students out of 20 students, and I want to assign these 4 students 4 different positions: president, vice president, treasury, and secretary. Okay, the answer is P. Okay, you use P, permutation, 20P4. Okay. So as you can see, the difference between permutation and combination is that permutation order matters. Combination order does not matter. Next, let's look at permutations with non-distinct items. The number of permutations of n objects, of which n1 are of one kind, n2 are of a second kind, and nk are of a kth kind, is given by n factorial divide n1 factorial times n2 factorial times nk factorial, where n equal to n1 plus n2 plus nk. Okay. So for example, in a basket, I have apples, red apple, yellow apple, green apples. So I have 3 different apples. If I have 4 red apples, 5 yellow apples, and 6 green apples that belong to this question. So n1 equal to 4, n2 equal to 5, n3 equal to 6. Okay, represent a number of different colors of apples. Okay. Let's look at this example here. How many different vertical arrangements are there of 10 flags? If 5 are white, 3 are blue, and 2 are red. Okay. This question is a permutation problem. Okay, 5 are of one kind. We have 5 white, 3 are of a second kind, blue, and 2 are of a third kind, red. So we use formula 10 factorial divided by 5 factorial 3 times 3 factorial times 2 factorial. And you get 2,520. So the final answer, there are 2,520 different vertical arrangements for 10 flags. Okay. This is the lottery problem. Okay. So next one, we take a complicated example about a lottery. Okay. The probability of winning is given by the number of ways a ticket could win divided by the size of the sample space. Each ticket has 2 sets of 6 numbers. Also, this is the question, okay? So this is the question, yes. So we start with the question, that is the explanation. So I will repeat, start all over for this question. In the Illinois lottery, an URN contains balls numbered 1 to 52. From this URN, 6 balls are randomly chosen without replacement. For a dollar bet, a player chooses 2 sets of 6 numbers. To win, all 6 numbers must match those chosen from the URN. The order in which the balls are selected does not matter. So the order does not matter, we should use combination. The question is, what is the probability of winning the lottery? Okay, so we know we need to use combination because order does not matter. Okay. Okay. So the probability of winning, how do we calculate? We calculate number of ways a ticket could win, then divided by the size of sample space. And in the given problem, each ticket has 2 sets of 6 numbers. So there are 2 chances of winning for each ticket. The sample space S is the number of ways that 6 objects can be selected from 52 objects without replacement and without regard to order. Okay, so the sample size is select 6 objects from 52. Because order does not matter, it is a combination. Okay, 52C6. So first, we figure out the size of sample space is a combination. Okay, choose 6 from 52 equal to 52 factorial divide 6 factorial times 52 minus 6 factorial. You do a little bit calculation, you come up with 20,358,520. So that is the sample size. Okay. And each ticket has 2 sets of 6 numbers. So a player has 2 chances of winning for each dollar. Okay. So the probability of winning ticket is 2 over the sample size. Okay. The result, the chance is very small. It is almost equal to 0. Okay. So there is about 1 in 10 million chance of winning the Illinois lottery. Okay. All right. So that is the counting technique. Okay. In summary, what we did in this video, we introduced the concept of counting, and we focus on the permutation and the combination techniques. Okay. Hope you enjoyed this video. Thanks for watching. I'll see you next time. Comment.